If the height of y in feet of a ball was thrown up in the air from the roof of a building after t seconds, right? It's given by this equation here. This scenario is different. The last scenario where we did this, we just dropped an object. We didn't throw it, right? But the relationship in both cases are time in seconds, the object is in the air, versus the height of the object from the ground, okay? So when you drop an object, you don't see a quadratic path. When you're standing on a building, no, and you throw something, right? It's gonna go up and then it's gonna come down, right? That path, the actual path in the air, represents a quadratic relationship, right? But that's not the relationship we're studying. We're still studying the time it took the object, or the time after the object left your hand versus the height that object is from the ground. So you're not writing the equation of the curve that you can see on the board, you're writing the equation of the time versus the height, which is given by this equation here, which we will give you. This has to do with projectile motion and gravity. So we give you this, right? And then the question is, what's the maximum height of the ball? You can use the image to kind of make sense of where the maximum height of the ball is going to be. Where's it going to be? It's going to be at the vertex. So what you're looking at is the path of the object, but the path, not the path, the relationship between time and height is also a quadratic relationship, so that highest point is going to be at the vertex, which is going to be up here. How do you find the vertex of a quadratic equation? There's three ways we have. If you have it in vertex form, right, you got the vertex. If you have it in intercept form, you have to average the intercepts. It's not in intercept form, it's in standard form. It's the easiest way to find the vertex from standard form. That's that other method to find the vertex. It's got A's and B's in it. It's a fraction. It's negative. Alexandra? Negative B over 2A. Yeah. So the vertex is always, from standard form, it's pretty easy to find. You got to do a little math, but it's a simple little relationship. The opposite of the B value by twice the A value, comma, and then to find the Y coordinate, we're going to plug the X value of the vertex into the equation. And that'll give us our maximum height. So this intimidating looking question is really only asking to find the vertex. So remember, A in this case is negative 16, B is 64. We don't even need C at the moment. We're going to use the relationship opposite of B, so negative 64 divided by twice A, which is negative 16.
2.
So negative 64 divided by 32. Negative 32, excuse me. Negative is positive 2. Good, Dimitri. Comma, question mark. How do I find the output, the Y coordinate? File.
Plug in it. You plug in X, well, your X coordinate.
Or, yeah, in this case, the T, but yes, you plug that into the equation, right? So I have now negative 16 times 2 squared plus 64 times 2 plus 50. Negative 16 times 4 is negative 64. Plus 64 times 2 is 128 plus 50. Leaving us with 64 plus 50, or 114. So the vertex, excuse me, is 214. The question didn't ask you for the vertex. What did the question ask you for? The maximum height of the object. So your answer is, the maximum height of the object is 114 feet after 2 seconds. Is it called an object or a ball? What is it?
Ball. A ball.
Make sure you include your units.
Would we ever need to use feet squared?
Not in this case, no. So the maximum height of the ball is 114 feet after, or at time equals 2 seconds. Good, questions? Feel comfortable with it?